All right, welcome back. This is at THS Mr. Jones. We are going to be talking about chapter 1.5, which is linear inequalities. Now, what is a linear inequality? Well, you should know what linear means. Linear is having a degree of 1. Okay, it is also when graphed makes a line. Okay, now we had linear equations, and linear equations gave you one solution. However, with linear inequalities, okay, so this part here went with linear. Equalities tells you, or inequalities, means to have a range of solutions. Okay, so in this case, I'm not going to have one solution, but I'm actually going to have infinite solutions. And that infinite solution is split up into a range. So I want to look at some of the symbols that we have for inequalities. Okay, so those are the 4 that we have. This one is less than. We have greater than. We have less than equal to. And we have greater than equal to. Okay, and we also have some other things related to each one of these signs. So the first thing we have is we have open circle, closed circle, and a closed circle. Okay, open circle means I cannot choose that number. A closed circle means I can choose that number, so it's used with equal. We have parentheses with these two. We will have a bracket, and we will have another bracket. Okay. And lastly, this is for when we get to two-dimensional graphing. We have a dotted line, and a dotted line. And here we have a solid line, and a solid line. Okay. So if it is open circle, parentheses, or dotted line, that means it cannot equal that number, so it's less than or greater than. If it is a closed circle, a bracket, or a solid line, that means it can be equal to that number, meaning I can choose those numbers on that range. So just for a quick example, you'll see some of this. So if I have, let's say I have this on my number 1, so 0, and 2. So let's say we have a parenthesis here, a bracket here, and I want all the numbers in between. Okay. That tells me that my x value has to be greater than -4, but less than equal to 2, because the less than equal to was the bracket and the parenthesis was the greater than. Okay, and this is called a double inequality. Now, if we have something that maybe looks like this, so 0 bracket and going this way, it actually goes on forever. That would be x is greater than equal to minus 5. But I could also write, okay, and I'll write it for this one up here. I can also write that it goes from -5 to infinity with a parenthesis. So parentheses also go with infinity as well. Up here on this one, we would write parenthesis minus 4, because that's what it used down here on the graph, and then comma 2 with the bracket. Okay. So we have unions and intersections. Okay, so let's talk about unions and intersections. So a union is formed by the elements of both sets. So we would say A union B. That's just kind of a big U. So union is the combined sets. So I use Venn diagrams a lot for this. So if I have this set right here, this is A. So A has a bunch of numbers in it. And if I have this set B over here, and it has a bunch of sets in it, so there are a bunch of numbers in it. The union is all of this stuff. Okay, it is the union of them together. Okay. We also have an intersection, and an intersection looks like this, and it is the subset that both sets share. Okay, so if I look at a Venn diagram here, we have A here, we have B here, and the intersection is where they both what they both have in common. Okay, what they both share. We call it a subset because it's a smaller group of the original. Okay, and you will have some of that with inequalities. By graph, in fact, we have it with this one right here. Really, this is an intersection because I have two inequalities here. I have x greater than -4, and I have x less than equal to 2. Well, if I were to graph both of those, okay, so here's 0, here's -4. We want x greater than -4, and here's 2, but we want x less than 2. So do you see how they keep going on forever? We actually want the intersection, which is where they both overlap. So just like on here, we wanted the intersection where both of my circles overlap. Okay. We can have union. Union would basically be everything. So if they don't overlap, maybe I have something that looks like this. Here's 0. We'll do -10, and maybe I go this way, and then this is 2, and I go this way. Okay, in that case, it would be a union because they don't overlap. So we want all those possible solutions. Okay, how do I solve these linear inequalities? So you'll do it just like linear equations. So just like linear equations, except one thing. And this one thing is super, super important. This is the difference in you getting it right and you getting it wrong by a long shot. So here it is. Maybe put a star by it. If you multiply or divide by a negative number, you must change the direction of your sign. Meaning, if I have this equation, let's just say negative 2x is less than equal to 4, and I divide by negative 2 because I'm trying to isolate x, divide by negative 2, I have to change the direction that this sign opens. So instead of it being a less than equal to, now it's a greater than equal to negative 2. Okay, you have to flip that direction of the sign because here's 0. Because before, maybe it was facing this way. Okay, but when I change or multiply by a negative number, it changed the signs of my answer. So I have to be back over here in that direction. Well, you can't even see that. Okay, it was going here before, but when I multiply or divide by a negative number, it changes the sign of the solution. Okay, which also flips the side of your number line that you were on, because you were positive and now you're negative. Okay. All right. So before I finish up here, here's some questions. Here, inequality. What is the difference between a bracket and a parenthesis? And then I want you to solve and graph 2x minus 4 less than equal to 6. Okay. All right, a couple more things here. How about doubles? So with doubles, a double inequality is just we can solve it 2 different ways. Okay. So if I give you something like negative 2 less than equal to 3x plus 5 less than 10. Okay, that's a double inequality, meaning there are 2 inequality signs. So we could take this and solve it all like this. So I'd take it, and what I do to the middle, I'd have to do to all 3 sides. So I'd subtract 5 minus 5 minus 5 and do it that way. If you don't like that way, you can split it up and do it separately. Okay, I've got some students that like doing it that way. That is fine. Okay. In the end, though, you'll probably get something like this blue one right here that we just did a little bit ago. Okay, you're gonna want to look for the intersection. Okay. Now, could it be like this? Possibly, but probably not. So you're gonna want to graph them both like this over here. You'll graph them both, and then you'll look at the intersection. Okay. I have to graph. Yes, you need to graph these on a number line. Okay, I've shown you some here. So all you gotta do is on a graph, you have to put 0. Okay, have to have a 0, and then you can just come out here for me and just put like you're at -7 and you're at 10. Okay, I need 0, and then you can put the numbers that you need. I don't need you to put a ton of different marks in there on that. Okay, that is for the most part that's 1.5. You will have a couple word problems in here. Okay, inequalities make great make great solutions to real life examples, because a lot of times in real life you don't need one answer, but you need a range of answers. Here are your suggested problems. Okay, starting on page 146. And on this time I changed the challenge problem to now it's what's the mistake in this problem. So in the book, it works out a problem for you, and then it just asks, what is the mistake? Can you find it? What did they do wrong? Sort of thing. Okay. If you need a lesson video, the lesson video will be right there to watch the stuff that I go over in class, and you can get some more explanation on linear inequalities on that. This is at THS, Mr. Jones. Thank you for watching.